have a triangle angle sum theorem, which just simply states that all triangles.
You don't have that thingy majigger that we had like last time? The paper with everything?
No, they've made us cut our print budget.
Oh.
I didn't turn this on.
Is there a green light?
Yeah, it's flashing.
Okay, so all triangles have an angle sum of 180 degrees. And it doesn't matter if you're talking about a right triangle, an isosceles triangle, equilateral, scalene, big, little. You have a triangle the same size as the whole plane, it's still going to be 180 degrees. And we can use that to find missing angles. So if we look at this example from the skills practice on 4.2, which is backwards. So in the packet it printed 46 and then 45. I ended up, somehow it got messed up, so it's page 45. You'll see the tiger pennant, and we want to find out what is this angle here. Well, we can subtract these two from 180 to find the missing angle. So you're going to do 180 minus 80 and minus 73. Yeah. Okay. Well, 180 minus 80 is 100. And then 100 minus 70 is 30. And 30 minus 3 is 27 degrees. So the measure of angle 1, that's this angle right here, would be 27 degrees.
You can just subtract 80 from 73.
No, I had to subtract both. All three together are going to add up to 180.
Okay.
So in any triangle, so we've had, if I angled this, or label that number 2 and I label that number 3, just hypothetically, then all three angles will always add up to 180. So to find the missing angle, I subtract the 2 I have from 180.
You only subtract.
If I only subtract,
from 73, it's just
if I only subtracted one of them, let's say I only subtracted 80, then these two together would have added up to 100. So I have to subtract both of them to find the missing one.
right. That's what I'm saying. Like if you were to subtract 80 and 73,
yeah,
would you still get? You would get the same.
Yeah, no. If I were to subtract 73 from 80, no.
Okay.
No, I have to subtract them both from 180. So like here on this one, do you see how angles 1 and 2 are marked like this? That shows that they're the same.
Yeah.
So what I'm going to have is
180 minus 146?
Yeah.
Do you divide by 2?
Yeah, you're going to have to divide by 2 because these two are the same, right?
Okay.
So they're the same. So all three of them together would add up to 180. So we're going to do 180 minus 146. And that's going to give me 34. But there's two angles here.
17.
Yeah. 17. So the measure of angle 1 and angle 2 are both 17 degrees. So because they're the same, we just divide by 2. Fine. So we're going to talk about this. Vertical angles are congruent. That's what this symbol means. And congruent means the same size and shape. Okay. So if we have angles that are across from each other, things that make an X, angle 1 and 2 are vertical. And then if I called this A and B, angle A and B would be convertible. Or vertical. Yeah. Vertical.
Wait, what?
So vertical angles, when you have things that make an X, you get two sets of vertical angles. The two, they're always across from each other. So A and B are vertical angles, and and 1 and 2 are vertical angles, and those are congruent, so they're the same size. Okay? So we use this fact, the vertical angles fact, to find all these missing angles. Okay? So to find angle 1, we'll use the fact that it's in a triangle, so it's going to add up to 180. So angle 1 is going to equal to 180 minus 85 and 40. Okay, so 180 minus 85 is 95, minus 40 is 55. So angle 1 is 55 degrees.
Oh.
So far, okay? That's this angle right here. Angle 1.
How did you get angle 1? Oh, okay.
Because they
That's
make up the triangle.
Oh, okay.
Yeah.
What if there's no number inside of it?
If there's no number here, you can still find
You just
that
okay.
angle. It would have a number, you just write in what the angle measure was. Okay, now angle 1 is congruent to angle 2. They're the same, right? So if angle 1 is 55,
Angle 2 is 50.
that means angle 2 is 55. So this one's also 55 degrees. Okay, that was this one. And now I know angle 2 is 55. This corner up top is 55. So now I can find angle 3.
Subtract 110 from 180.
Yeah. So angle 3, I'm going to do in, we think purple? Okay. So angle 3 is going to be 180 and then minus those two 55s. So that's 110. So 180 minus 110 is 70.
Okay, so.
So what we're doing, hold on, I'll walk back through it. Let me just, I'll keep going. All right, so we look at this triangle first because we have all of the angles and we're just missing this one. And that's, we found the first angle, angle 1, by subtracting those two from 180. Okay, angle 1 and angle 2 are going to be equal because they're across from each other, they're
So you
vertical.
subtract 55 minus 55 to get angle 3.
Yes. So I found angle 1, and then that told me angle 2, and then I subtracted again to find angle 3. Good?
Mm-hmm.
When we talk about the exterior angle theorem, we first need to know what an exterior angle is and what remote interior angles are. Okay? So if you look at a triangle, so this triangle here, and you extend one of the sides out. And we could extend along this way like we did, or you could extend this way. But if we extended on the second one, this first one would have to be gone. Okay? You can only extend one way and have an exterior angle. So you extend one side of the triangle out longer, and it forms an angle on the outside of the triangle. That's the exterior angle. And it makes a straight line with the vertex angle. So it's always going to be a straight line to be an exterior angle, and it makes a linear pair. So for example, if I were to draw something like this and I did that, this angle right here is not an exterior angle because it has to be a linear pair.
It's a vertical angle.
It's a vertical angle. This angle would be an exterior angle with this side, these two. And then this angle would be an exterior angle, but that angle would not be. Okay, does that make sense? It has to be a linear pair. Yeah. So that angle 1 in this picture is your exterior angle. Your remote interior angles are on the other side of the triangle. Remote is far away. Right? If you talk about remote locations, they're far away from here. So the remote angles, the remote interior angles are inside the triangle and they're the furthest away. So they're on the other side. So that would be angles 3 and 4. Because they're far away from angle 1. okay?
I'm not paying attention because I'm writing, but it will. It's a little slow, but I'll get this.
But the definitions are making sense of what parts are which, because you have to know those before I can give you the theorem.
What, you need to write a definition first before I get the theorem.
Not yet, I haven't written the theorem yet, I just wrote what the exterior
Oh,
angles
okay.
are, what the interior angles are, and then I'll give you the theorem, but I want you to know, won't do any good to know the theorem if you can't identify the angles. So are the angles okay? Good, yeah? Alright, so the theorem is that the exterior angle of a triangle don't have to write the word, right? Cool. The exterior angle of a triangle is equal to the sum of the remote interior angles. Okay, so in this instance, the example triangle, angle 1 would be equal to angle 3 plus angle 4. Okay, and here's why that works. Angle 3 and 4 and 2 add up to 180, right? Yeah, so if I do 2 plus 3 plus 4, I get 180. Well, if I do 2 plus 1, I also get 180, because that's a linear pair. So if I add 3 and 4 to 2 and get 180, and I add 1 to 2 and get 180, that means 1 has to be the same as 3 and 4. That's how that works. So the outside angle is equal to the two remote interior angles. That's our theorem. Right? So if we have angle 1 is an exterior angle.
It's outside right now.
Yeah. So it's going to be equal to the remote interior angle. So the ones across from it are these two. So angle 1 is going to be equal to 55 plus 70. So like in our drawing up here, if this is angle 1, this would be our angle 2, and these two would be our angles 3 and 4. Is that,
What did you, I'm sorry.
if you took this triangle that we drew up here and like flipped it around,
Right.
then if this was angle 1, our exterior angle, this one right next to it would be angle 2, and 70 and 55 would be our 3 and 4. So angle 1 is going to be 70 plus 55. So that's going to be 125 degrees. Okay. Now angle 2 is a vertical angle. So angle 2 and 55 are going to be the same.
Well, why did you have 55 and 70?
Because that's what our theorem tells us, is if we have this exterior angle, we take the two angles across from it and add them together.
Question about the first one. Had I just went ahead and added up, instead of adding them up, if I would have just subtracted both of those from 180, I would have gotten
This angle here.
that one, so then I would have, I mean, I know this is the wrong way to go about it, but it's just
No,
another way of
you
doing
can get there, yes, you can get there that way. You could,
180.
it's longer. Because you could subtract each of these from 180 and find that this angle was 65.
Yeah,
No, sorry, 55.
I'm just saying if I was filling in all the angles, because you never know.
Yeah, 55. Then you would take 55 and subtract it from 180 to get this angle. It's the long way around. It's faster just to add those two together. Now, that would work for this side, but that process won't work for this side. Well, no, yeah, I guess it would, because you could subtract that from 180. Never mind, it'll still work. I know that 2 is 55, and I know that this exterior angle is equal to 2 plus 3. So to find 3, I take 150, and I subtract angle 2 from it. And I would get 95. But you still could go the long way around. You could take the 150 and subtract it from 180 to get this corner angle here, and that would be 30. And then you'd say that this is 55 and that is 30. If you subtract those from 180 to get angle 3. So you can go the long way around. This is just a shortcut. But if you can get to the right answer, you know. Okay, so we want to find angle 1. Okay, I know that angle 1 and 2 add up to 180, but that doesn't do me any good because I don't know angle 2. But angle 1 is an exterior angle, so I'm just going to label that as an EA for exterior angle. Okay, so it's going to equal these two added together. So angle 1 is equal to 80 plus 60, because those are my remote interior, they're on the other side. So that's going to be 140. Okay, so I'm going to go ahead and label that as 140.
Then you subtract 140 from 180?
Yeah, then I'll find angle 2. So for angle 2, because those two are straight lines, so they'll add up to 180, I can subtract 180 minus 140, and I get that 40 degrees. So this one's 40. And then this angle here is also an exterior angle to these two. So I can find angle 3 by subtracting 40 from 105. And I'll put that in a different color.
What are you finding angle 3?
Well, angle 3 is this 105, this blue one that I put EA on. That's an exterior angle to this triangle. Actually, it's exterior to both of those. This one with the 2 and the one with the 4, but it's exterior to the angles with the 2 and the 3, and the 2 and the 3 are on the opposite side of the triangle. So 2 plus 3 would equal 105.
Okay.
So to find angle 3, I'm going to do 105 minus angle 2, which is 40. So that's going to give me 65.
So when you add all 3 together, it'll equal to 180?
Yeah. And then, I forgot to write down. Alright, then angle 4 plus angle, this EA, the blue one, these two angles make a straight line, so they're going to add up to 180. So I can subtract 105 from 180. Wait, green or orange? Orange, okay. So for angle 4, I'm going to do 180 minus 105, and I'm going to get 75. So that's 75. And then angle 4, the 75 degree, and this 40 degree are the remote interior to angle 5. So to find angle 5, I can add those two together.
And then minus 180?
Oh, no, I don't have to subtract them from 180, because once I add these two, I'll know that one. Number 5 on the outside. Because the sum of the two inside ones on the are equal to the outside one. So that'll be 115. Now, that's not the only way you can go about it. You can use the fact that the triangle will add up to 180, and I could have found this missing angle here using the triangle's 180, and then use the fact that this angle and number 1 would add up to 180, and found angle 1 that way, and then I would have known angle 2 because these two are vertical. So there's more than one way to get about this. It's just that the exterior angle theorem is the shorter way. It's the faster way, it's the shortcut, but that's not the only way.
When you add 40 plus 75 plus 115, it'll give you 180, right?
No, it'll be angle 5 out here
Oh, no, no.
is equal to these two together. If I add 40 plus 75 and this angle right here, then I'll have 180.
But since the 5 on the outside.
But since the 5 is on the outside, it's equal to these two added together by itself. Does that help? Okay? Okay, a corollary. A corollary is like it's a theorem that is the direct result of another one. Sort of like a PS at the end of a letter. You know, you've written your whole letter and then you send it and you, oh yeah, by the way, also this. It's like a direct result of the fact that you're already doing the letter. So the corollaries are, people came up with theorems and they go, oh, okay, well that also means this and that. And then those would be the corollaries. So the corollaries from the triangle angle sum theorem. So you've got that the triangle adds up to 180 degrees. Well, that gave us two more things that, oh, well then this means these. So because a triangle adds up to 180, if you have a right triangle, the other two angles are complementary. They'll add up to 90. And if you think about it, that has to make sense, right? Because if this is 90 and the whole thing is 180, well then these two also are 90 together. Right? Because 180 minus 90 is 90. So there's 90 left over for these two. And then we also get that there can only be one right angle and only one obtuse angle in a triangle, because if you think about that, that also makes sense. Triangles have to be exactly 180 degrees and they have three angles. If one of them's 90, there can't be another angle that's 90, because that wouldn't leave anything left for the third angle. You can't have a 0 degree, angle, right? And then if one of them's more than 90, it's obtuse, it's 100 degrees or something, you certainly can't have another angle that's more than 90 and still maintain your 180 degree triangle. So these two are things that kind of logically fell after the fact that we discovered triangles had to have 180 degrees in Euclidean geometry. That's not true in some other geometries, but in Euclidean geometry it's true, where we live on the surface of the planet. I told you about the hyperbolic and the elliptical geometry and things, but we don't live in them. There's other geometries for other dimensional spaces. We don't live in those spaces. So while these are true in our space, they're not necessarily true in other dimensions. But we're here on Earth. So this is always true.
Okay.
We can use the 90 degree part to find other angles. If we look at this triangle, I have a 90 degree angle here, which means I also have a 90 degree angle here. Both of these will be 90 degrees. And if this is 90 degrees, these two have to add up to 90 degrees. So to find angle 1, I can just do 90 minus 63. And I use, well, I don't have to use the whole 180 because I know that this is 90, so there's only 90 left. Does that make sense? So you can still do 180 minus 90 and then minus 63, but you can skip the 180 part and just go straight to the 90 if you have a right triangle. So I have 90 minus 63, that's 30 minus 3, so it's 27. So that's angle 1, 27. see, that one's also 90 degrees, that whole thing. And then angle 2 and angle C are gonna add up to 90,
Yeah.
because this one's already 90, so these two will be 90. And I already did that math. I have two triangles, essentially. I have a little triangle like this that was 90 and 1 and 63. And then I had the big triangle like this that was 2 and 90 and 63. See how I took that? I took this little one out.
Okay, don't have to.
I don't.
This part right here is this. The whole picture is this. If we took this line in the middle out, it gave us this. Yeah.
So was it just showing the iron on the left side by B in reference to the little triangle?
Yeah, well, what you have is, whenever you have, I need more space, hold on one second. Buttons, there it is. Whenever you have a situation like that, we have a line that's perpendicular to another line, they'll only ever mark one side, but both angles will be 90. So anytime you see that, the other side is also gonna be 90.
So angle 1 and angle 2 are both 25?
Yes. And this particular triangle, that won't always,
Be like that.
no, that's true, it'll always be like that.
Oh.
Yeah. If you're talking about that particular angle of 1 and that particular angle 2. Now, if I mark this angle here, then those aren't the same, these two aren't the same.
Okay.
And we're gonna actually talk about why this is the case, that that particular angle 1 and this particular angle 2 are gonna be the same every time, when we talk about similar triangles. Which, congruent are same size, same shape, similar, same shape, different size.